Writing and using two-column triangle congruence proofs. Let's start with a question. What is the difference between a definition, a postulate, and a theorem? Give an example of each. How confident are you in knowing the difference between these terms? What would you say in response, and what example would you give? I started with the word postulate. It's a statement that is assumed to be true without proof. The example I gave was the segment addition postulate. And then I moved on to theorem. It's a statement that must be proven. The example I gave is the Pythagorean theorem. And a definition is a statement that gives the meaning of a word. An example is a circle is a set of points all equidistant from a center point. Now let's think about some big ideas regarding congruent triangles. If two triangles are congruent, right, so they are exactly the same shape, exactly the same size, then every pair of their corresponding parts is also congruent. Once you know that two triangles are congruent, you can make conclusions about their other corresponding parts. By parts, we mean angles or sides, because corresponding parts of congruent triangles are congruent, or we use the 5-letter acronym CPCTC. You can use CPCTC to prove that corresponding parts are congruent after proving the triangles are congruent. Now let's look at this example of two triangles, and in the diagram that we see, some sides are given as congruent, there's a pair of angles that are given as congruent, and there's some numerical measures for two of the angles and one of the side lengths. We can see that in the first triangle we have two sides and the included angle of that triangle, congruent to two sides and the included angle of the second triangle. So we could use side angle side and complete that congruent statement that triangle DOG is congruent to triangle. Now the order of the letter matters. So to go from D to O to G, I've gone up the side with one tick mark, down the side with two tick marks, is congruent to triangle CAT. Now that I have this congruent statement, we can use it to solve for the three unknowns, starting with the measure of angle T. When I look in the diagram, angle T, the measure is not given. But when I look at my congruent statement, angle T, which is the third letter in the statement, corresponds to angle G, which is the third letter in the first triangle. The measure of angle G is 32 degrees, therefore the measure of angle T is 32 degrees. The measure of angle D comes first in the three-letter name of the first triangle. So angle D corresponds to angle C. Therefore, the measure of angle D would also be 87 degrees. Side CT, that length is not given, but the first and the third letter, CT, correspond to the first and the third letter in DOG. Therefore, CT and DG are congruent, so CT also equals 13 inches. Now we're going to try our first two-column proof here. Whenever we have a two-column proof, the first column will be statement, the second one will be reason. I filled in the reasons for you. And we have a diagram. There's some tick marks that are given to show congruence, and we have to prove that angle A is congruent to angle D. According to the diagram, we don't know at first glance that A and D are congruent, but after this proof, we'll be able to state why they are congruent. So we always start with the given information, and I'll say that side AB is congruent to side DB. Also given in the diagram, side CA is congruent to side CD. These two triangles share a side. They share side BC. So by the reflexive property, we can say that BC is congruent to itself. Now we have three sides in the first triangle congruent to three sides in the second triangle. So by side, 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 triangle congruence postulate, we can say the triangle CAB, notice the order that I'm traveling around those letters, C to A to B, is congruent to triangle CDB by side, side, side. And now I can prove by CP, CTC, that angle A, which is the middle letter in the first triangle name, is congruent to angle D, the middle letter. We'll move on to a second example. This time, our two triangles are given in the diagram. They don't share a side, but they touch at an angle. And in fact, where they touch, I can see that it looks like there's a pair of vertical angles that are there. And I have to prove that angle Q is congruent to angle T. So we always start with the given. QP is congruent to TP. Another piece of given information. Side RP is congruent to side SP. Now by vertical angles being congruent, we can say, and we're going to use the three-letter name of these angles, that angle QRP is congruent to angle TPS. Now we have two sides in the included angle of one triangle, congruent to two sides in the included angle of the second. So by side angle side, triangle RPQ is congruent to triangle what? RPQ is congruent to triangle SPT. And now I can state that angle Q is congruent to angle T. Notice those angles both come last in each triangle name by CP, CTC. Now we're going to try a proof, a two-column proof, where I haven't given you the statement or the reason. All I've given you is the diagram, some markings, and a statement that I want you to prove. How would you get started on this example? Hopefully you know that we always start with the given information. That side JK is congruent to side LK, and that's given. There's two right angles, and we can state that angle KMJ is congruent to angle KML because all right angles are congruent. Now these two triangles share a side, KM. KM is congruent to itself by the reflexive property. So now we can make a statement about whether or not these triangles are congruent. And we think, which postulate could we apply? And we've got 5 of them we can choose from. Whenever there is right triangles, I like to see if hypotenuse leg is my reason. And in this case, the hypotenuses of both triangles and that leg that they share are congruent. So we can say definitely that triangle JKM is congruent to triangle LKM by hypotenuse leg, HL. And now side JM, notice in the congruent statement, it's the first and the third letter, side JM is congruent to side LM by CP, CT, C. How did you do on the two-column proof where none of the statements and none of the reasons were given? We'd like you to summarize what you learned about writing and using two-column proofs for triangle congruence. It's important when you're learning something new to pause and write down what's important to remember.